Tyler, hi.
Yep. Hi.
Hi. Uh, okay, we'll give it another minute. Tyler, so have you reviewed these materials which I sent today?
This from the links on this spreadsheet.
Yeah, the links. I also sent a video.
Yeah, I haven't had a chance to look through it all yet today.
Yeah, I'm really interested about this ARC thingy because it's multi-cloud thing. So maybe it can be used for loading data. I'm not sure.
Yeah.
Okay, so I guess let's start, right? So today will be another boring review of different interview questions. But before that, I wanted to share this. So what happened, there was a Microsoft Ignite event on November 2, 4, right? And they made a lot of announcements. So here is a list of some of them. So first of all, Azure and Open AI. So Open AI is a company. I think I'm not sure. Original idea was maybe Elon Musk, maybe some other people. They pledged billions of dollars because they believe that AI should not be corporate. It should be open source because if one corporation will have strong AI, it will have unfair advantage. And Musk is afraid of that. So anyway, they created a lot of good models, and one of them is GPT-3, which is a third iteration of their language processing model, which has more than 170 billion parameters. I mean, it's a huge, huge thing. It costs millions of dollars to train, and now it is available in Azure. So you can use it. It's a pre-trained model, of course, and there are other models. So this is very exciting, and there's a YouTube video where you can watch some stuff about it. So it's OpenAI with Microsoft, right? Another is a service for Azure data labeling. Now it's multi-class, it's AI assisted. So what you do, you start labeling your data and you assign labels to different images, and then you ask algorithm to, well, based on what I already labeled, try to automatically label and provide like your confidence level. And so you go back and forth between manual correction and automatic labeling. So this makes data labeling much more effective. Another thing is Azure Arc. So you have multi-cloud on premises, Azure, Edge, all together. So it uses Kubernetes, which is the way how to orchestrate the, gosh, what is it called? Docker deployments. Okay, so this is interesting. I don't know how it works. Next is Azure Video Analyzer platform. This is really interesting because you can analyze videos in real time. You can extract information. You can also analyze audio in this video, make transcript, and then you can do some sort of machine learning or analysis based on the data you extracted. So this is really a new platform, very interesting. Another is Azure Language Studio. So we had machine learning studio, now we have language studio. And it's already working, so you can try to use it. Very convincing. Another is Container Apps Preview. Well, we before we could create we could deploy model, we could create endpoints, right? Kind of like a website, you send it some JSON, it returns your prediction. Now they made it better, more convenient to use. So you can create kind of like one domain with different services. So here's a video with the demonstration how it uses, how it works. And another is Azure Percept. Well, Percept, I guess, because it is from the word sensor, right? So you have edge devices, mostly they're sensors of some sort. So it's IoT, right? Internet of Things. And now they have this Azure Percept, which deals with that. And they have joint ventures with companies which produce those sensors or produce some software to process it. Even Dell, for example, many hardware vendors. Okay, so this is the gist of it, and you can follow the links. And I will stop sharing. Michael, and I now pass it to you.
All right, so I guess I'll share mine now. All right, guys, so we're going to continue on here with the ETL section of the data architecture interview questions. We're going to start with this one right here. How does late arriving data affect dimensions and facts? Share techniques for handling each. There are two types of late data. One is the late fact table data, and the other is the late dimension table data. Late arriving dimensions, sometimes called early arriving facts, fact data arrive earlier than dimension data referenced by fact rows. When fact arrives, we can use natural key to identify if corresponding dimension data is available. Natural key, for example, social security number. Surrogate key is system generated identity column. What do we do with the fact data if dimension data is not available? One approach is to put this fact data into a suspense table for later processing. Another approach is to assign the unknown dimension to fact record for later processing. For a fact record with SCD type 2 dimension versioning, it is necessary to judge the occurrence date of the fact record before insertion, whether the dimension record has changed so far, and if there is a change, the fact record needs to correspond to the dimension record when the fact occurs on. Also, after the fact record insertion is complete, the aggregate fact table and the merged fact table related to the fact table need to be processed accordingly. For late dimensional records, the processing we need to do is more complicated. First, the late dimensional record is entered into the data warehouse for the first time. Then a dimension record needs to be generated in the dimension table, and the corresponding fact record need to be updated. Foreign key pointing to this dimension record. Secondly, if the late dimension record is a modification of the original dimension, then we generate a new record in the dimension table. We also need to find the fact line of the dimension from the current change to the next change and the dimension foreign key, then update to the proxy keyword for the new dimension. Does
Tyler,
anybody have any comments on that? I know that was very involved and intricate. I'm not completely sure you would want to give an answer like that at an interview. But that is kind of what he said here.
Yeah, I found that to be kind of difficult to follow. Just the way that was phrased.
So, just judging by the question, how would you say it?
Let's see. Well, yeah, I agree with that first, like the bullets there with the fact data. What do we do with that if the dimension data is not available? And the two approaches of either putting the records into a suspense table and process them later once you do have the dimension data, right, or just assigning the unknown dimension. And then from what I could tell, it sounds like the intent then is that whichever approach you take, you still need to, I guess, retain that raw data so that once the dimension value does come in, that you can reprocess those records and assign the fact records to the appropriate dimension.
So it sounds like a more generalized, like basically like kind of what you just said, as opposed to giving a technique that he outlined, right?
Right.
Yeah, I definitely agree. So, I mean, I think I would do the same. I mean, so this here is a good kind of summary of the situation, and then an overall view of keeping in mind the thing you mentioned, that you still have to take care of that stuff, but not giving the whole technique of it. which yeah, like it just not very easy to follow.
Right.
Misha, you know what
Yes.
the funny part? Can you return back to it?
Sure.
So the top part, which Tyler liked, was actually written by me today.
Oh, well, that's great.
and what goes after that for the fact records is the type 2 dimension and so on. This was the original text. Like,
Oh, well, that makes a lot of sense.
Yes. Great, Lev, as usual.
Yeah. No, I mean, it's true. You don't want to give answers that a person, like, sure, they might be correct to an extent or whatever, but you don't want to confuse somebody, especially if you're at an interview.
Right.
So let's go to the next one then. Describe the different types of ETL metadata and provide examples of each. Metadata is a very important topic facing the ETL project team and is a very important part of the entire data warehouse project. There's no definition of the classification and use of metadata. I would say, like, there's not one specific definition, not definitive definition. That just sounds odd. Generally speaking, we can divide the metadata into three categories, namely business metadata, technical metadata, and process execution metadata. Business metadata is a description of data from a business perspective. It is often used to help report tools and front-end users analyze and use data. Technical metadata is a description of the data from a technical perspective. Usually includes some attributes of the data such as data type, length, and some results after data profiling. Processing metadata, which is some statistical data in the ETL processing process, usually includes how many records are loaded and how many records are rejected. Share acceptable mechanisms for taking operational metadata. Operational metadata, which is the processing metadata, records the data migration in the ETL process, migration date, number of records loaded, and so on. This part of the metadata is very important when the ETL fails to load. In general, for data loading using the ETL tool, content such as migration scheduling time, migration scheduling order, failure processing can be generated by the definition in the migration tool. Data such as the date of the last migration can be saved. If you're writing ETL programs by hand, the processing of operational data metadata will be more troublesome and you need to get and store it yourself. State the primary types of tables found in data warehouse and the order which they must be loaded to enforce referential integrity. The basic types of table in the data warehouse include dimension tables, fact tables, subdimension tables, and bridge tables. The subdimensional tables, the snowflake model, is processed by the scaffold dimension technique, and the bridging table is used to process multi-valued dimensions or hierarchical structures. The various types of tables that need to be loaded in the data warehouse have interdependent relationships, so they need to be loaded in a certain order. Here are some basic principles for loading. After the child dimension table is successfully loaded, the dimension table is loaded. After the dimensional table is successfully loaded, the bridge table is loaded. After the child dimension table, and bridge table are loaded, the fact table is loaded. The loading order can be determined by the relationship of the primary foreign key. What steps do you take to determine the bottleneck of a slow-running ETL process? The first step is to determine whether the bottleneck is caused by CPU, memory, input-output, network, etc., or the bottleneck generated by the ETL process. If the environment does not have a bottleneck, you need to analyze the ETL code. At this point, we can use the exclusion method. We need to isolate different operations and test them separately. If ETL tools are used, the current ETL tool should have the function of isolating different processes, which is relatively easy to isolate. The analysis is best started from the extraction operation and then analyzes the processing operations of various calculations such as lookup table, aggregation, filtering, and finally analyzes the loading operation. In the actual process, you can follow 7 steps below to find the bottleneck. So isolate and execute the extract query statement. Isolating the extracted parts first, removing the conversion and delivery, extracting the data directly into the file. If this step is inefficient, it's basically a question of extracting SQL. From experience, untuned SQL is one of the most common causes of poor ETL efficiency. If there is no problem within this step, go to the second step. Remove the filter. This is for the full extraction and then filtering in ETL processing. Filtering in ETL processing sometimes creates bottlenecks. You can remove the filter first. If it is determined for this reason, you can consider data filtering at the time of extraction. Exclude problems with lookup tables. Reference data is usually loaded into memory during ETL processing. The process is to do lookup and replacement of code and name, also called lookup table. Sometimes the amount of data in the lookup table is too large and can cause bottlenecks. You can isolate the lookup table one by one to determine if there is a problem here. Note that to minimize the amount of data in the lookup table, usually a natural key can be used as a surrogate key, which can reduce unnecessary input-output. Analyze sorting and aggregation operations. Sorting and aggregating operations are very resource intensive. Isolation of this part to determine if they cause performance problems. If it is determined that this is the case, you need to consider where you can move the sorting and aggregation processing out of the database and ETL tools and move them to the operating system for processing. Isolation and analysis of each calculation and conversion process. Sometimes the processing operations in the conversion process will also cause the performance of ETL work. Gradually isolate them to determine what went wrong. Be careful to observe things like default values, data type conversions, and more. Isolate the update policy. The update operation is very poor performance when the amount of data is very large. Isolation of this part to see if something went wrong here. If it is determined that the performance issue is due to large batch updates, you should consider separating insert, update, and delete separately. Detect database input-output for loaded data. If there are no problems with the previous section, the last thing to check is the performance of the target database. You can find a file instead of the database. If the performance is improved a lot, you need to carefully check the operation of the target database during the loading process. For example, if all constraints are closed, all indexes are closed, and the bulk load tool is used, if performance is not improved, consider using a parallel load strategy. Now, when you're troubleshooting your pipelines, Tyler, do you kind of follow similar kind of steps, or is this guy going a little out of the regular path?
No, I'd say that pretty closely follows the types of things that I would do when trying to troubleshoot.
Yeah. Yeah, it seems like he's got a good set of steps there. I mean, it's not all worded in perfect grammar, but I think the idea was right.
Right.
Describe how to estimate the load time of a large ETL job. Evaluating the data load time of a large ETL job is a complicated matter. Data loading is divided into two categories.
I'm sorry, Michael. To go for this, I don't know if it's important or not for point
Sure.
number 13. One thing what I observed, sometimes people do not use all options which is available for ETL loader. For example,
Oh, okay.
load data. For example, there are options to parallel initiate multiple concurrent direct load load sessions, I would say. Okay, concurrent load sessions, which will allow to insert data in the same table parallel. And this option, when it was omitted, for example, one example, it was omitted in the beginning, but when they discovered this, it dramatically increased loading of the data. So I would say it's, I don't know if it's a valid or not, but it's one of the, sometimes we do not ever, we do not use what is loader, what the tools are giving us options to perform it faster. So it was like my observation.
Right. So you're saying that sometimes like certain useful tools are actually overlooked.
Yes,
and as
exactly.
a result,
Yeah.
you get, basically not as efficient as you could be.
Exactly. So it was interesting. We were using for many years the same approach, and then we realized it's available, especially with later versions. So it increased actually, I would say 60%.
And so would you say that that was primarily because you guys hadn't used that loader very much, or because literally you just didn't know that that was there?
Nobody paid attention to this one. Just it was developed 7 years ago, and we were using over and over. And then we realized data is growing now. It became very slow. So instead of 13 hours, it became 4 or 5 hours to load.
Wow. Oh, so
Yeah.
you guys were using it at that inefficient way, but then you realized that if you just did this a little differently,
Yes.
with something that was available right there, that
Exactly.
it changed everything.
Yeah. So
Yeah, I understand what you mean. I've had this experience before with other things.
yes.
So like doing it like a certain way, and then you realize there's something right there that could speed things up. Yeah, so I guess the moral of the story is to really investigate the tool you're using and see the features that are available to see if you could, jump some of the effort instead of like going at it, the path you might think is the best one.
It was travel, I don't know, discovery. Honestly, it was, and everyone like, wow, it was always there. we never use it. So.
No, I totally understand what you mean. That makes a lot of sense. Yes. I think that's a good thing to keep in mind because, it's so easy to think you have the exact solution. And then, you do it and it takes a long time, but you think that's the way, right? And then like what you're saying, there's like a tool right there that you just overlook. So I guess it's very important to definitely look into things like that.
Yes. Motivation of this because data became huge and we realized it's not working right way. See,
right.
Now, we have to deal with big data and so on. Tools are available. Okay. Small addition.
No, I that's a very good thing to bring up. I've encountered the same situation in different circumstances. It's definitely, I think also, one thing I found helpful is literally looking it up online just to see the different approaches people have straight off the bat. And this way kind of it gives you an idea if maybe a tool has something you're not aware of, So that's kind of how I do it, that kind of thing as well.
Great. Yes. Okay. Thank you.
All right. So describe how to estimate the load time of a large ETL job. Evaluating data load time of a large ETL is a complicated matter. Data loading is divided into two categories, the initial load and the incremental load. When the data warehouse is officially put into use, an initial load is required, and the time required for the initial load is generally difficult to predict. In the daily use and maintenance of the data warehouse needs to be incrementally loaded every day. The amount of data loaded incrementally is much smaller than the initial load. To estimate the load time of the initial load, the whole ETL process needs to be divided into three parts: extraction, conversion, loading, and the three parts are evaluated separately. Evaluation of the extraction time. Extracts most of the time that is normally occupied by ETL and is very difficult to evaluate this part of the time. In order to evaluate this part of time, we can divide query time into two parts. One is the query response time, and the other is the data return time. The query response time refers to the time from the start of the query to the start of the result. The data return time refers to the time when the first record returns to the last record. In addition, the amount of data loaded for the first time is too large. We can consider selecting some of them to evaluate the overall time. In actual processing, we can select the partition of the fact table. Generally speaking, the amount of data in each partition is similar, and the amount of the time of one partition is estimated, and the number of partitions can be used as the overall evaluation time. Evaluation of data conversion time. Data conversion work is usually done in memory, generally has a very fast speed, accounting for a small portion of the total time. If you want to evaluate time required for this part, the easiest way to evaluate is to first evaluate the extraction time and load time, and then run the entire process, subtracting the extraction time and load time from the overall time. Evaluation of load time. There are many reasons that can affect load time, the most important of which are indexes and logs. The evaluation of the load time can also be a part of loading the data, such as loading 1/200, calculating the time and multiplying by 200 as your overall load time. Offer techniques for sharing business and technical metadata. In order to be able to share various metadata, there must be some metadata standards in construction process of the data warehouse. And these standards should be adhered to in actual development. These standards include metadata naming rules, storage rules, and sharing rules. At the most basic level, companies should set standards in the following 3 areas. Naming rules. The naming convention should be set before the ETL group starts coding, including database objects such as tables, columns, constraints, indexes, and other coding rules. If the company has its own naming rules, the ETL group should follow the company's naming rules. When an enterprise's naming rules do not fully meet the requirements, the ETL group can formulate supplementary rules as new rules. Change to the company's naming rules need to be documented in detail and submitted to the relevant department for review. Architecture. The architecture should be designed before the ETL group starts working. For example, the ETL engine is placed on the same server as the data warehouse, or the server is set up separately. The data preparation area is built to be temporary or persistent, whether the data warehouse is based on dimensional modeling or 3NF modeling, and these should be documented in detail. And the basic structure, the system infrastructure should also be determined first. For example, is the solution based on Windows or Unix? These enterprise infrastructure metadata should be developed before the ETL team begins work. These should also be documented in detail. In the development of ETL, the metadata standard is well established and can be well adhered to. So the metadata of the established data warehouse can be well shared. Describe the architecture options for implementing real-time ETL. When building a data warehouse, ETL usually uses batch processing, which is generally run every night. With the gradual maturity of data warehousing technology, enterprises have higher requirements for the time of delay of data warehousing, and there is real-time ETL that is often used. Real-time ETL is a relatively new part of the data warehouse field. There are several techniques to choose from when building data warehouse for real-time ETL architecture. Micro-batch ETL. The way of micro-batch processing is very similar to our usual ETL processing, but the processing interval is short, for example, 1 hour apart. Enterprise Application Integration, EAI, is also known as functional integration, which is usually done by middleware. The usual ETL is called data integration. For systems with very high real-time requirements, consider using EAI as a tool for ETL to provide fast data interaction. However, the use of EAI tools when the amount of data is large is relatively inefficient and relatively complicated to implement. CTF, Capture, Transform, and Flow. CTF is a relatively new type of data integration tool. It uses a direct database to database connection method, can provide second-level data. The disadvantage of CTF is that it can only be lightweight data integration. The usual way to do this is to create a data preparation area that uses the CTF tool to connect between the source data and the database in the data preparation area. After the data enters the data preparation area, it is migrated to the data warehouse after other processing. EII, Enterprise Information Integration. EII is another relatively new type of data integration software that provides real-time reporting to businesses. EII is handled in a similar way to CTF, but it does not migrate data into the data preparation area or data warehouse, but instead loads directly. In the actual establishment of real-time ETL architecture data warehouse, you can choose more or combine all of these above mentioned ways.
Okay, hold on a second. I'm completely confused. So, for example, Azure Data Factory, right? Where it goes?
My guess is that it seems like what he's describing are Well, I mean, in Azure Data Factory, you kind of decide how you want to do things, right?
Yeah, I think Data Factory is largely for batch ETL. So, I mean, you could schedule it to the point where you are doing micro batch ETL. I would say of these options, I think that's where Data Factory fits.
For the large batch.
For large batches or the micro batches, even.
The
I mean,
micro batches,
because you can schedule it on any
right, the
any type
trigger
of
can be
cadence that you
whatever.
want.
Yeah.
I'm confused. So Azure Data Factory under the hood, it can do parallel loads, right?
It can, yes. I would say you'd have to be careful with the way you've coded it if you are going to be doing like you're talking about just multiple executions of the same pipeline.
Okay, so for example, number 4 here can be done using Data Factory, and number 3 and number 2, all of them, in fact, number 1, all of them may be implemented using Azure Data Factory, right?
Possibly, yeah. I'm not very familiar with 2 through 4, and even the explanations there. Yeah, I think I'd need to do a little deeper dive to really fully understand what's going on with each of those.
Well, just out of curiosity, I mean, it's. So this sounds more like almost Power BI type of stuff, you know?
Right.
Maybe it's like a very old explanation, which is obsolete.
That's what I'm guessing. To be honest with you, what I think we ran into here is these are concepts that exist, but with the way we do things now, we don't really think of them that way. That's my guess. I mean, let's see what this one, CTF, capture, transform flow, is that like something that is out there as a thing? Oh, looks like it is. But it looks like it goes back 10 years. Roughly.
Yeah.
So I think maybe it was a definition that existed, but we don't really hear it too often. I agree with you. This is what I thought too. I thought, well, we could do most of these things. Like you could use, you know, Synapse, you could use Azure Data Factory, and you could kind of design the strategy of how you want to do things, right? I mean, you might be better off using some other tool for specific things, but I feel like, yeah, you kind of mix and match these approaches within there.
Yeah. I mean, because yeah, Azure Data Factory, you know, you can configure it so that you can call pretty much any other resource within Azure that you want to, and there are other resources that can do, you know, like stream processing.
And now I know we're kind of running out of time, but I wanted to ask you this, Tyler. Like Azure Data Factory was kind of the prominent ETL tool offered by Microsoft, but now it seems like things are switching over to Synapse Workspace. Is that correct?
For the most part, I would say so, yes.
It's like, isn't Synapse almost like a rebranded Data Factory with just added functionalities?
In a lot of ways, yes. The functionality is very similar. There are a few capabilities of Data Factory that haven't yet been ported over to Synapse.
Right. Is that most to do with like SSIS?
I think, yeah, SSIS is one, and then there are a couple other things that I haven't really used a whole lot. I'd say for 95% of the functionality, give or take. there's feature parity between the two.
Right.
But yeah, I do get the sense that Microsoft really is trying to encourage people as much as possible to use Synapse.
Yeah.
And I think largely because, it is such an integrated environment. You have that nice Synapse Studio that allows you to do a lot of different things just in one location and not have to hop around between different
Right.
different
Yeah, they're
resources in
definitely
Azure.
pushing on it.
Right.
Yeah, I mean, I've encountered, the suggestion that you should use Synapse,
Right.
Well, it looks like we have 2 minutes left in this meeting, so probably not worth it to go through this next question, but thank you guys for joining today. Thanksgiving's coming up. I hope everybody has some good plans in store, or at least have a good break,
Yes, exactly.
By the way, will we be having a seminar next week?
Well, it will be Thanksgiving, right? So
Right, it'll be the Friday after
no.
Thanksgiving.
Yeah, actually, it would be preferable to skip. Next week would be great.
Yeah, we'll skip it.
Okay, cool.
Fantastic.
Okay. Cool. And the two questions which are left for ETL, like 17, like it makes no sense because it lists different combinations of those techniques, which are obsolete.
Right.
And,
So we could X that out.
and it gets from like 1 minute to 1 hour to 1 day, depending on the combinations. But how they combine it, what exactly like software they use, I would just remove this question. It's
Yep, I will. Yeah.
it makes no sense. And then question 18 outlines some challenges and describe continuous intervals, snapshots to achieve data. Yeah, well, I think it makes sense, right? But we can discuss it next time. It's good to spend some time on it. Okay.
Yeah.
Thank you.
Cool.
Thank you.
All right, guys. Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thanks, everyone.
Okay.
Bye.
Happy Thanksgiving, everybody.
Thank you.
Yeah,
You
happy
too.
Thanksgiving.
Thanks.
Thank you. Thank you. Bye.
Bye.
Bye.